All right. After coming off the addition, subtraction of polynomials, and then we did some multiplying of polynomials, we were going to talk about what's called a binomial expansion. And it's called a binomial expansion because bi meaning two, these have two terms in them, 3x plus 4 in this case. Okay, so two terms, just an a plus a b, and then it's raised to some power, some exponent. And when we say expand it, what that means is carry out the multiplication. And so you got to be very careful here. Some students goof this up and they go, oh, I'll square 3 and I'll square 4. No. It says take 3x plus 4 times itself one time. So you have to write it down twice, like this. And then you have to distribute, okay, which we've practiced the other day. 3 times 3, x times x. 3x times 4. Then, get a better green color. 4 times 3x, that's 12x also, and 4 times 4. Let's add up our like terms in the middle. So there it is, expanded, 9x squared, 24x's plus 16. Notice how it does this nice job. When we get done, it goes 2, then x to the first, then x to the 0. We just never show that part. But it goes 2, 1, 0. And that's our standard form, remember. We always go from highest degree to lowest degree. We wouldn't show this, though, and we don't show that. But it is in standard form. And so that's pretty easy. I expanded that binomial by squaring it. But we get bigger. Assignment, everybody. And that should be it. What if I have to do x plus 5 cubed? This expansion is going to take a little bit longer. Okay? Let's write him down 3 times because that's what it means. Take it times myself 3 times. The way I generally do this is I multiply these two first. You could multiply the first two together. It doesn't matter. I just like to do the second two because I think it makes the last multiplication easier. So I've got this x plus 5 I'm not touching yet. And I distribute. That's x squared plus 5x. And I distribute. That's 5x plus 25. Now before I carry out the next multiplication, I'm going to clearly add some like terms here. Because I've got 5x and 5x. That's 10x's. And now I've got to distribute this x to everybody. That's x cubed. 10 times x is 10x squared, 25 times x. And then 5 times x squared, 5 times 10x, and then 5 times 25. 5 quarters is 120 or $1.25. And I add my like terms, x cubed plus 15x squared plus 75x plus 125. Now that was only to the third power, so wouldn't it be great if there was a shortcut for this? And there is. And we're going to take a look at that shortcut with this problem right here and verify that our shortcut works, at least for this problem. And this shortcut involves using what is called Pascal's triangle. And here's how Pascal's triangle goes. And you can write this down. You don't have to memorize it. You just memorize the pattern. You start with a 1, and then you offset 2 1s. Then you're just making a triangle, okay? But in this gap, what you do is you add those two together. And you go 2, and then you put a 1 on the outside. Then you put a 1 on the outside. Here's a gap. You add those together. There's a gap. Add those together. 1 on the outside. Gap, add them. Gap, add them. Gap, add them. Then a 1. And we can go on. This thing goes on forever. Gap, add them. Usually you don't draw these little arrows. I'm just showing you what I'm combining. And I'm running out of room there. But I could keep going. All right. So let's see how we can use this Pascal's triangle to expand this binomial that we've already completed. Okay, so we should get this answer when we're done. And the way you do it is you go to the line that has a 3 for the second thing in it, and that's this line right here. 1, 3, 3, 1. And you write those down. 1, 3, 3, 1. Now, for the sake of room, I'm going to erase my Pascal's triangle. I already got what I needed from it. That 1, 3, 3, 1 pattern. Okay, I'm going to give myself a little more space up here. Hopefully. There we go. So 1, 3, 3, 1. Then all you have to do is with your highest exponent, and your first term is you just go x and you write your highest exponent. Then you go x and you go down 1. Then you go x and you go down 1. That's x to the first, and then you don't have any x's. Okay? So that was pretty easy. Then you take your second term, the 5, and you do the reverse with it. At the very end, you start with a 5 cubed, then you go a 5 squared, then you go a 5 to the first, and then you go no 5s. And now all you have to do is simplify each of those terms. Watch this first one. Well, that's 1 times x cubed. That's just x cubed. Okay? This second one, I've got a 3 times an x squared times a 5. Well, 3 times 5 is 15. So that is 15, and then I've got that x squared there. Oops, I don't want that. There we go. 3 times 5, 15. So 15, and then my x squared. Here I've got a 25, 5 squared, times this 3 right there. So 3 times 25 is 75, and then I've got that pink x to itself. And finally, 5 times 5 is 25 times 3, or times 5 again, a third time, is 125. And you can see these two match up perfectly. And I didn't have to do all of that multiplication. Let's try a tougher one using past example. All of this work, that was just to the third power. You can imagine Gauss triangle. Okay? Ooh, 2x to the fourth now. Just got to be careful. Now, because it's cubic, okay, I just memorized those, but we can generate Pascal's triangle pretty quick. Watch how quick you can do it. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Bam. That's the one I want. It's got the 3 in it. Okay, so I'm using 1, 3, 3, 1 again. Again, give yourself plenty of space between these as you write them down. So I go 1, 3, 3, 1. All right, now my first term is not x anymore, it's 2x. So I do the same thing I just did, but I go 2x, and it starts with the third, the highest degree, and it just keeps going down. 2x to the second, 2x to the first, I don't show the 1, and no 2x's. Then I grab my 4, and I go from the other end. I go 4 to the third, 4 to the second, 4 to the first, and then no 4's. And now I just have to simplify these. Okay, so I got a 2, and he's cubed. 2 times 2 is 4 times 2 is 8. 8 times 1 is just 8, and I got to cube my x also. 8x cubed. The next one, I got to be careful. This is a 3. 2x, I got to square it. That's 4x squared, and then times that 4. So I have to calculate 3 times 4 times 4. That's 16 times 3, or 12 times 4, however you want to think of it. That's a 48. And then I've got an x squared in there. Next one is a 3 times a 2x times a 4 times 4 is 16. So let's see if we can figure that out. That'd be 6 times 16. So I'm doing this, that's 6. And I still got to take it times the 16. 96. That's 96, and it's only got that x. And then lastly, I have to take 4 times 4 is 16 times 4 is 64. There we go. We're done. Look at, we're nice and standard form. 3, 2, 1, no x's. And we aren't going to check it because I do not like to multiply that together 3 times. Last one. Ooh, x plus 2 to the 5th power. I don't have that one memorized, so I'm going to generate Pascal's triangle real quick. 1, 3, 3, 1, just adding in the gaps. 4, 6, 4, 1, 1, 5. There it is. That's the line I want. 5, 1. I'm going to need quite a bit of space for this. So I want 1, 5, 10, 10, 5, 1. So I'm going to write them down here. 1, 5, 10, 10, 5, 1. Now I'm going to erase a little bit so I don't have this guy in my way. Hopefully I can just grab him and delete him. There we go. Oh, awesome. It did them separately. I wonder if this works. Nope. I'd have to group them. There we go. Maybe a little more space between them. Piece of cake. Because our first term is just x, so the x goes x5. Oops, I don't need parentheses here. X to the fourth, x to the third, x to the second, x to the first, no x's. The 2 starts at the other end. 2 to the fifth, 2 to the fourth, 2 to the third, 2 to the second, 2 to the first, and then no 2's. All right, 1 times x to the fifth is x to the fifth. Here we just have a5 times an x to the fourth times a2. Well, 5 times 2 is 10. 10x to the fourth. Here I've got a 10 times an x cubed times a 2 times 2 is 4. So it's 4 times 10. That's 40, and that's x cubes. Here I've got a 10 times an x squared times a 2 times 2 is 4 times 2 is 8. So that's 80 x squareds. Here I've got 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's a 5 times an x times a 16. That's also an 80. And that's just x. And then lastly, I've got 2 to the fifth, which is, I just did 2 to the fourth is 16, so times 2 again is 32. And I just did a very tough problem. But not too bad. Very little work to show. All right. Your homework is just a series of these. Okay. And you can use Pascal's triangle, or you can grind through it like I did on how much work you'd be doing if you did this one straightforward with grinding through it. Hopefully that helps you get through your